Now, good morning. Today we are going to learn experiment number 6. The title of this experiment is implementation of decimation process. Okay, this is the sixth experiment for digital signal processing lab. Okay, so under the digital signal processing lab we are going to perform total 8 experiment. Out of that, this is the sixth experiment. Okay, so the title of this experiment is implementation of decimation process. Okay, so here what is the decimation? Okay, so see, decimation is the process of reducing the sampling frequency of a signal to a lower sampling frequency that differs from original frequency by an integer value. Okay, so keep it in mind. Okay, so decimation it is just a process, okay, of reducing the sampling frequency of the signal. Okay, it lower the sampling frequency and it will be different from the original frequency, okay, by an integer value. Okay, so in simple word we will say decimation is nothing but a down sampling. Okay, just it is very simple, down sampling and up sampling of the signal. So that's why in this same way here we will say decimation is a down sampling process. Okay, here the low pass filter associated with the decimation and it remove the high frequency content from the signal to accommodate the new sampling frequency. Okay, so this is the basic concept behind the decimation process. Okay, so what the basic concept behind is, the low pass filter is associated with the decimation process. Okay, it will helps you to remove the content from the signal to accommodate the new sampling frequency. Okay, so decimation is useful in in application in which the Nyquist frequency of a signal is much higher than the highest frequency of the signal. Okay, decimation filter will helps you to remove the excess bandwidth and reduce the sampling frequency of the signal. Similarly, the decimation filter also help you to reduce the computational resources required for processing and storing the signal. During the analog to digital conversion process, decimal decimation filter is also reduces the variance of quantization noise in signal and it maintain the signal power. Okay, it also improve the signal to noise ratio. Okay, so here I am showing you how you can utilize this decimation concept. Okay, with the help of this. Okay, so here one diagram is shown. Okay, and with one equation we are going to represent here the decimation process, that is y of n is equal to x into m of n. Okay, so this particular function we are going to design with the help of MATLAB. Okay, so here how this decimation process will be carried out with with the help of example. Okay, so see, we are switching over the MATLAB. I hope you can able to see the MATLAB prompt. Okay, along with here the program is written for in MATLAB. Okay, for the decimation process I am just highlighting the code. I hope you can able to see it. Here first statement is variable f is written. Okay, it is used for defining the frequency, so that's why f is equal to input in bracket enter the frequency of signal. Then p is used for the whether you want to enter as an interpolator or decimator. Okay, so that's why here the factor of the interpolator or decimator will be decided with the help of p. Okay, that value you can able to write. Okay, so that's why p value will be decided by you. Okay, so that's why whether it will be greater than the p or whether it is less than the p. Okay, so that's why here you are sorry, whether p is greater than n or p is greater than smaller than n. Okay, so that will be decided by you. So interpolator or decimator factor will be entered by you in this p variable. Similarly, the n will be the length of the signal. Okay, that will be decided. Mm. So here fourth statement is telling you here we are going to plot the signal from 0 to n minus 1. So that's why it is written as t is equal to 0 colon 1 colon n minus 1. Okay, if you plot it, okay, if you put it in the MATLAB prompt, only t is equal to that much value will be given for that values. Okay, then here only a simple function is written, x is equal to sine into 2 pi ft. See, you know the formula, x is equal to sine 2 pi ft, so that's why 2 is multiplied with 3.14 pi, okay, into f into t is given. Okay, and value x is calculated. Okay, that value is passed to this decimate name function. Okay, in our MATLAB decimate name function is there, so that decimate name function is demanding the two parameter, that is x and p. So we go over that decimate function. Okay, see, the decimate function will be looks like this. Okay, here just I maximize this. So decimation means decreasing the sampling rate. Okay, so whatever the sampling rate this that we have to decrease, okay, that will be depending on the total three parameters. So that's why here the x and r is compulsorily necessary to define it. So the sampling rate of x is reduced by the factor r. Okay, so here that's why the x and r are necessary. As this function is operate over the Chebyshev filter, okay, means internally this decimation process will adopting the Chebyshev functions filter concept. Okay, so here one example is given you in the help. Okay, that will tell you about how the decimation process is carried out. Okay, so here t is defined with x and y. Okay, and decimation process is carried out. Okay, so we are going to see the same thing with the help of our MATLAB program. Okay, so I am just switching over the MATLAB. Okay, see, just I close this help, so I go over the program. Now once this decimate function will accept the value x and p, okay, we able to get we got the value of d. Okay, we will get the decimated value. Okay, that decimated value we are going to display, okay, or plot with the MATLAB. Okay, so that's why here subplot concept is adopted. Okay, with this subplot we will stream the value of x. Okay, similarly we will stream the value of d. Okay, now these things are plotted. These statements are help you to plot the decimation signal. Okay, the original signal and decimated signal are represented. Just I run the program, see how you will get the result. Okay, now here we need to enter all these frequency. Okay, so that's why here I already kept some values like 100 will be the frequency signal. I already calculated from one of the problem, so that's why frequency of the signal will be 100, interpolation or decimation factor is 5, and the length of the signal is 50. So just I enter it 100, 5 and 50. So I enter 100, 5 and 50. Okay, once you enter you will get a graph. Okay, see the graph. Okay, from this graph here you will able to see the differentiation between the original signal and the decimated signal. So downsampled signal will be seen on in this graph. Okay, below the original signal. So the original signal will be sine. Okay, sine 2 pi ft will be the signal represented with the help of this function, and decimated signal will be shown. That decimated signal will be reducible, or you can say क्या बोलते उसको. Okay, it is a downsampled, or it will be passed to low pass filter. Okay, low frequency signals are passed. Okay, so that's why here you got the decimated signal in this way. I hope with this you got the idea about how you can do the decimations of the signals. So I hope it will be enough for your understanding how you get the decimations, how you understand the decimation of the signal. Okay, so this is about our sixth experiment in the digital signal processing lab. Hope you are doing it well. Okay, hope you are doing it in our MATLAB. Okay, so that's why I try to do it over your MATLAB, run it and see, observe the output. If you have any difficulty, you can text me over our WhatsApp group. Okay, so I think these things are enough for your understanding. So I am quitting this experiment. Thank you very much.